All right, so today we are going to look at horizontal dilations of sine of x, and we're going to combine them together with the vertical dilation stuff from yesterday. Okay, so we'll do a couple graphs here, but first we'll review what we looked at yesterday. So yesterday, right, we looked at changes in amplitude or vertical stretches of the graph of sine. So I have three different colors here, blue, red, and green, and those are all represented here on the graph. Okay, so you can see the different changes that those lead coefficients there of 1, 2, and 1/2, how they affect the graph, right? You can see that the stretch, right? You can kind of see that. Remember that when it comes to graphing our sine function, right, that we start, kind of at 0, we go out to 2 pi, and then rather than having you find, all those, unit circle or reference triangle angles, of like pi over 6, pi over 3, pi over 4, 2 pi over 3, 3 pi over 4, 5 pi over 6, all that stuff, I just have you find the starting point and stopping point of your period, so 0 and 2 pi, finding the halfway point, so in this case pi, and the quarter points, or the halfway of the halfway points, okay? So pi over 2 and 3 pi over 2. And then you can evaluate those using a table if you want to. Eventually you'll just get, you'll remember these kind of things too. You can think about your unit circle as well if that helps, whatever you need to do to help you remember that. Of course the table works too. Okay, you make a little chart, XY chart. Fill those in and stuff like that. The x coordinates from, again, these numbers right here, and find the matching y coordinates. Either way, you'll notice that while the vertical stretches, right, change how it's, the height of the wave and the depth of the wave, what does not change are the zeros, right? Also, the length of the period, right? The period length, all these waves repeat every 2 pi. They all start at 2 or 0 and they go out to 2 pi and continue on, right? You could also say they start at 2 pi and go out to 4 pi, and then from 4 pi out to 6 pi, and then from 6 pi out to 8 pi, so on and so forth, right? Likewise, they go backwards too, from 0 to negative 2 pi, from negative 2 pi to negative 4 pi, negative 4 pi, negative 6 pi, so on and so forth, right? But this key piece of information right here, the standard untransformed period, right, because we're not stretching or shrinking horizontally at all, we're only stretching or shrinking vertically like that, okay? So the stretch shrink horizontal is not happening, so that's kind of our standard period is from 0 to 2 pi. So when we get down to something like this, where we see the 2 in multiplied with the x, that indicates a horizontal stretch or shrink. And the way we're going to take that, or we're going to, kind of like, work with this, is take that 2x and put it right in here, between the 0 and the 2 pi. Okay, and then we're going to solve for x. Okay, so how would you solve for x here? What would you do? Well, you would divide everything by 2, right? And so dividing everything by 2 yields 0 less than or equal to x less than, oops, not 2 pi, right? 2 pi divided by 2 is pi. So our new period for our graph is 0 to 2 pi. So we're going to start at 0 and go out to pi. Okay, so again, we can go and start making our coordinate plane here. So okay, now in an effort to try and compare to what we had before, I'll try and line up the pi from up here. So, we'll say the pi is right here. So I really kind of went way too far. Okay, so whoop. Okay, and we'll still put the 1 and the negative 1 here and the 0 there. Okay, so now when it comes to graphing, 0 is the starting point still, because we didn't shift left or right at all. We're just shrinking it. And then, but pi is now the end point of my period. So I'm going to fit one full wave in here. But what numbers do I use? Well, just like we found the numbers up here, you're going to find the midpoint and then the quarter points. Okay, so do the same thing here. So what's halfway between 0 and pi? Well, it's pi over 2. What's halfway between 0 and pi over 2? That's pi over 4. What's halfway between pi over 2 and pi? Well, again, you can add them up. So you can do pi over 2 plus pi. Well, we can't add them because we don't have common denominators, so I can make it pi over 2 plus 2 pi over 2, right? Now we have common denominators. 3 pi over 2, like that, okay? And then that's the sum, and we have to then further divide that by 2, which is the same thing as multiplying by 1/2, which gives us 3 pi over 4. Okay, so then 3 pi over 4 is the midpoint here. Okay, and now we will graph. So I'll do that in red here. So at 0, 0, if you plug in pi over 4, you're going to get 1. At pi over 2, you're going to get 0. At 3 pi over 4, you're going to get -1. And at pi, you'll get 0. Okay, if you plug those in your calculator or something like that. And you just connect the dots. Okay, now compare that to, let's say here, y equals just sine of x, the normal sine of x here. What would that look like? Well, here's what the normal sine of x would look like in green. So okay, and of course it would continue on. Okay, that's kind of pointy, but you get the idea at least. Okay. Well, we could actually fit a whole other... Whoops, I messed up here. We actually fit a whole other period of the sine of 2x in, so 2 full periods of sine of 2x inside of the sine of x there, okay, between them kind of thing. So you get the idea, okay? But anyway, there is the difference. You can see that kind of horizontal shrink, right? So a 2, okay, again, does the opposite of what you'd expect. Kind of like anytime we have a number in with the x, we're adding or subtracting it, it goes, you know, the opposite direction of what you'd expect. You know, if it's x plus 2, it's going to shift left 2. If it's x minus 2, actually shift right 2. The number in with the x there also, you know, if it's 2 times x, like we've got right here, that's going to be actual shrink of twice, or divided by 2, or 1/2 the period length there. Okay, so you can see that shrink. Okay, so now let's try one where we have a 1/3. So that's going to result in a period stretch, right? Because it's going to increase the period. So again, we'll take what's in the parentheses there and put it between the 0 and 2 pi, our standard period. In this case, we'll multiply everything by 3. So I'll get 0 less than or equal to x less than 6 pi. So now 0 to 6 pi is the period that we're going to be using. And so when I go to set up my graph here, again, I'll try and kind of line things up. So let's see, I said 2 pi was like right here. So then 4 pi would be here, and 6 pi would be here. Okay. And I probably don't need any of these other ones to help me. Okay. And then 0. You get y and x. There's no coefficient in front there, so the amplitude is still just going to be a 1 to -1 there. Okay, we didn't stretch vertically at all, just horizontally. And again, this is our new period. So how do we find the other points that we wanted to use? Well, again, halfway point. So halfway between 0 and 6 pi is 3 pi. And the quarter points. Halfway between 0 and 3 is 1.5, or 3 pi over 2. And halfway between 3 and 6 is 9 pi over 2. Okay? And again, we'll just plot our points. So plug in 0, you'll get 0. Plug in 3 pi over 2 to this function right here, and you'll get 1. Plug in 3 pi, you'll get 0. Plug in 9 pi over 2 to the function, you get 9 pi over 2, and then 6 pi. And again, just connect the dots. Okay, and voila, and again, it continues on. Okay, like so. Now, comparing that to, again, the original y equals sine of x. So let's see here, I have to kind of adjust things a little bit here. So if I wanted to fit the actual just normal sine of x in here, let's see, if that's 3 pi, then pi would be like right here maybe, and 2 pi would be like right here maybe. Not quite. Like right there, and right there. Okay, that looks a bit better. So we'll say that's pi, that's 2 pi. 3 pi over 2 should fit right in between those, but again, not perfect, but you get the idea at least here. And there's pi over 2 there. Okay, and so the normal sine graph would look like this. Okay, like that. So again, you can see that that 1/3 x there, that resulted in a horizontal stretch of 3 times. Okay, it's 3 times stretched out there. Okay, instead of ending at 2 pi, the wave ends at 6 pi. Okay, instead of, you know, starting, well, it still starts at 0 because 0 times 3 is still 0. Instead of peaking at pi over 2, it peaks 3 times that amount later, so at 3 pi over 2. Instead of bottoming out at 3 pi over 2, it bottoms out 3 times further, 9 pi over 2. Okay, and that kind of thing. So now let's put it all together and do a vertical and horizontal dilation simultaneously. What kind of transformation is 2 going to do in the front? A vertical stretch. And what will the 1/2 do? A vertical or horizontal stretch as well. Okay, so we're going to get stretches in both directions there. So again, I'll take what's inside the parentheses there, the 1/2 x, put it between, multiply everything by 2 to get rid of that 1/2, so we get 0 less than or equal to x less than 4 pi. Okay, so now I will go and set up my axes. And again, I'll try and kind of like line things up a little bit, just so we can kind of like just keep a nice scale. So let's see here, 2 pi I said was right here, so 4 pi will be like right there. So there's 4 pi. There's 2 pi, we'll see. Well, I'll get to those other ones here in a second. Now, when I go to set up my y-axis, I also need to be cognizant of the fact we have an amplitude of 2, which means that I need to indicate that we're going up to +2 and down to -2, right? Because our amplitude is going to be twice as big, so 2 and -2 are going to be the highs and lows. All right. Again, we have our starting point of our period at 0. Ending point of a period at 4 pi. I already have the halfway point, 2 pi, so I'll just get the other quarter points in there, 2 pi and 3 pi. And we'll just plug those in. So plugging in 0 into the function here, 1/2 times 0 is 0, sine of 0 is 0, 0 times 2 is 0. Plug in pi, 1/2 times pi is pi over 2, sine of pi over 2 is 1, 1 times 2 is 2. Plug in 2 pi times 1/2 is pi, sine of pi is 0, times 2 is 0. 3 pi times 1/2 is 3 pi over 2, sine of 3 pi over 2 is -1, times 2 is -2. And 4 pi times 1/2 is 2 pi, sine of 2 pi is 0, times 2 is 0. Okay, and again, there's the graph. We can extend it forever if we want to in that direction, Okay, again, just for comparison's sake, let's go ahead and just put sine on there just so you can see it. So sine would only be between the 0 and the 2 pi right here for one full graph. Again, I'll put the quarter points in there, so it'll be like this. And there, for comparison's sake, is just the plain old graph of sine of x. And again, continuing on like that. Okay, so you can see, again, it's half the height, right? And also half a shrunk as well. Or, well, yeah, sorry, if you double the width of this, you get the width of the transformed function. Okay, and if you double the height of this, you get the height of the transformed function too. All right, anyway, that's all. I'll give you guys 1 or 2 graphs to do for homework. Thanks for sticking with me. Have a good day.